All right, welcome back. Last time we looked at how to compute our GPA and passed, which is the first step in performing landmark data processing. Okay, so now that, don't forget, if you're not familiar with kind of what I'm talking about here, you have to understand what is called morphometric analysis of landmarks. All right, whether you are digitizing the face or an animal or plant or leaf, whichever you are digitizing, you have to understand the concepts. Okay, that's the morphology. Okay, so we have dealt with that last time. All right, so as I was saying last time, I was able to get you a sample digitized copy. All right, this is it. Okay, can you see here? This sample already have been digitized by USDG. So you can see, if you zoom out very well, you can see there's a this each point on each basis 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these points I show you in Microsoft Word now. Each point, okay, if you check again in Word, let me see. See each point here. See, so you can see for one, this one is for endocanton. This endocanton. Okay, two, you have exocanton. You have three, you have that's exocanton left, endocanton left, exocanton left, endocanton right, exocanton right. Okay, so that is how you can see them down. You can see down here. So uh, you can see this nation. The nation here is number 5, which is this 5 here. We have pronace, chromatesis. No. This one is different. But this is the landmark actually. But this the face is not corresponding to this number. Okay, I've changed them later. Okay, during the processing. So because pronounce is not in 6 now. This one is different one. All right. So but note that this is just the face interface I'm talking about. This is the face. But the landmarks numbers is it's not the same now, but the same landmarks actually, but the numbers has changed. I've rearranged the numbers. Okay, so I changed the numbers later because of another work I did. All right, so but it's just the interface of the face image, one of the image that I digitized. All right, so that is just so you can digitize like this as well using a TPS ditch or HAR, but TPS ditch is very fast and it's easier. So let's bring in back our TPS now and compute our PCA, principal component analysis now. So let's do that now. I don't know if you really understand this particular concept. I mean, this morphometry is not for everybody actually. For those who are in the field, who are researchers in that field, who want to do their work very easily and fast, they can use a pass to do that. So that is this one is meant for. All right. So this is the what we used last time. So I can just select all here. Okay, select all, and then I can go to motivate here. But before I do that, I need to. I've not yet. I didn't save last time when I compute my GPA, generalized post analysis. I didn't save, so I want to do that now again, and see the difference. So landmark. I want to first do for Bookstein 2D. All right. So I've done the Bookstein 2D. So based on this now, I want to compute PCA now. So I go to motivate here. Ordination, I click on PCA. Okay, this is principal component analysis here. So when I click here, so it computes for me. Now look at it. So it gives me this result, this eigenvalues and the variance. So these are this first PC. Okay, the first PC give me 44%, 44.4%, and second PC give me 26.156% approximately. The third PC give me 17.9, fourth PC give me 2.8. Okay, if you go to scatter plot here, This is scatter plot. Even though I have not colored it, so you can't see the difference between each of the races, okay, or by gender. So I've not colored it yet. So by color, you can see the difference here. So this is a score, PC scores. This PC score is very important. We're going to need it later and copy it out later. All right, for further use. Then this is just a loading plot. This is loading plot. This is loading score. This is script plot. This script plot is very important also. You're able to understand the concept of broken stick. Okay, so this one you can say that one, two, three principal component analysis is chosen here. Okay, you can see the cut it from here. So you can see it. So if I say okay, broken stick, I want to know. So I have to count 1, 2, 3. So the cut is from here downwards. This elbow method. Okay, so you can see the eigenvalue say this component, principal component. You see, you count three principal components, 1, 2, 3, right, under 5. So I can take 1, 2, 3, or I can just take 5, only 5. Okay, 1, 2, 3 but because the cut is from here, it's not from here. I can choose the first 1, 2, 3 is the major principal component that I needed. Okay, so that is that. Then if periodicity for purpose of the what do you call it now? We were talking about parametric assumptions now. So that's in the 3D scatter. So you don't need that for here for now. Okay, that's not needed for now. So this is summary. So now this is just the variance. You can copy the score. What you need to copy here is this score. Okay, if you need this you don't need to bother about this later. We're going to work about this later, and we're going to color it later to see the difference. That you can use a confess all here, or I mean confess all on eclipse. So because no color yet, so it's not giving me a different kind of color. So I'm going to color later. I'll show you how to do that later in the next probably the next class or whatever. So but I just have to show you the difference between PCA now. So now this PCA is for the boosting, all right, boosting GPA. So but I want to use a pro school GPA as well. So to see the difference. Now, if you look at this score very well, I mean this particular summary, order this variance, it's telling you that the first PC have 44%, second PC 26%, and third PC 17%. And this one has already almost more than 60% of the entire GP, entire variances that contribute to the landmark, all right, variances. So this one seems to be well distributed as far as I'm concerned. Okay, look at another one now. If I just note this, okay, note this. Don't forget. Let me close this now. I want to undo from here. Undo. Okay, I undo back to my normal data. So I come again as a landmark. Proscoot. Now I want to do the former one was boosting. So let's try Proscoot now. So 2D. Okay, click on OK. So it has changed. Now I come here now. I say okay, multivariate, continuation, PCA. You can see the difference between that one. You can see the first PCA give me 74%. I mean, the first PC, the variance give me 74%, while second give me 6%. This one is orthogonal because the variance is concentrated on particular PC, too high on on one PC. You can see it's not well distributed. You can see the first one PC give me 74%. It's good for some other purposes. Okay, in this case now, I can just take the first and second PC. That's all. Now, if you look at your scatter plot here, you can see it's not well arranged. Look at what it look like. You can see. Let me see if you can see it. If you see my score here, look at the score here. Look at the script plot. Can you see? Only give me only one. Only one that is give me on that broken stick. Wherever that one give me 3. So what does that suggest to us? It means that for a proper landmark analysis, it's better to use a boosting, okay, than a proscoot. Okay, the reason is because the data is spread, okay, better than when it comes to proscoot. All right, so because you need more of those data to spread properly so that you can be able to have a better data analysis. All right, so because this one is too concentrated on one PC, 74. percent is too high on one PC, why do you want just 6%? So this is not good enough, all right? So you need to use boosting. So if you want to put, what you need here is PC score, okay? But now we're not going to copy this now. We're going to copy PC score later for boosting. So let me just show you how to do that quickly. You can even see that this scatter plot is not generating properly. You can see now. You can see how it look like. Just you can see just one line like this on one particular dimension. Okay, you can see along the y-axis, which is not good enough. So that is that better. So let me go back to our boosting. Okay, let me go back. So transform again. Say boosting. All right. So I go back to now again. Ordination PCA. You can look at it now. So we have 44, 26, which is better. It spreads. Okay. Now look at my split plot. Now we have 1, 2, 3. So that which is good. Now, so here now you can copy the score here. This is the score you need. This is what you need for later data analysis. You need this score. I can just say copy here, right? Just a copy, right? The copy I can come to Excel. So just paste here. And see, yeah, just paste. So this is I think PC1, PC2, PC3 like 4. So this is ID. Let's call it ID. So this is ID my PC. So I can now here I can include. Let me include some start here. I can say race. I can say race. This is my race. So now how do race? I can say Africa. Okay, let's say Africa. Let's say Africa. Then sorry. All right. So here I can just drag. So anyone that's having here in front is automatically African. Don't forget that. Don't forget our naming convention. That's what's important. It's help you to organize the race properly. Organize your the data properly. So you can see this. That's African. Stop at A. Okay. So you can now come down again. This S for Asia. So you also Asia. Then drag down a little bit for Asia. Just stop here. Then W for Europe. Just say Europe. You can see it's white. Okay, so that is done. So I've automatically naming my. Can you see? Once and for all, I've named. So it make my work easier. So I can also do the same for race, for me, for gender. I can insert another one here. I call it gender if I like, but I don't need I need to complete that for now. So I can say okay, the middle one is F, all right, this is female. I can just say female. So whenever there is F, I just put female there. All right. Whenever there is AM, I put male. So here this female to this place, female. Then male here. So this have to do the search properly. This male. Same thing applicable to others. Okay, go to the other one here. We also say F female here. So for F, you may just drag it down for F. Right. Likewise here for male. That is middle letter. Don't forget this M middle letter here. It's giving us for M, so don't forget that. That's our naming convention. All right. So for Europe also we have F for female. Okay, you drag down. Okay, drag down more. We stop here. Then for the rest for male. Okay, yeah. So that's what we are done. So fast like that. So we are done. Can you see? We have created two major categorical data now. This factor data now, categorical data for analysis, and you can generate our PCs. Can you see? So we don't need all the PC actually. We don't need a PC. We need 1, 2, 3 later for analysis, but at least we have gotten. So if you copy your variance, for example, let's go back now. Let's say we want to see the summary. You copy the variance here, copy, and come here, you paste in Excel. Let's say we paste here in Excel. How many PC that gives us at least 95% CI? So let's say we copy this from PC1 to PC10. Let's say if you want to PC10 first, let's try copy here. Just want to confirm or to sum 97 total 97. PC1 to 10 97%. Okay. How many PC give us? But total PC we give 100% actually. So the only 10 PC give us 97%. So other one they are 0.00 they are very small. So now you can let's say 5 PC. Let's say 6 PC. Let me use 5 PC first. And so how many we get? Okay, so 93. I want 95. So let me say 8 PC. Okay, that means 7 PC can go. So let me try 7 PC now. Okay, good. This 94.96, that is 95 approximately. So 7 PC gives us 95% CI or confidence interval. Variance computation. So this is very good. So if you want to compute something, you can use 7 PCs. It will be nice. All right. So that's just the method. So now you can keep this PC. All right. You can keep it saved. All right. So this is your PCA that is data now. You can use this PC for machine learning. All right. To compute machine learning to find this race. You already have your race now. This become your target variable. Okay. So automatically, this become your uh, response variable. So your normal data that you want to use to compute. So that is that for now. So I will see you on the next class. Thank you so much.